Hello everyone. So in this video, I will discuss some integrals of trigonometric function, just the basic forms. If you recall, previously we learned about how to find the derivatives of trigonometric and inverse trigonometric functions. So today we're gonna learn about the corresponding integrals of the forms that we have done earlier in case of derivatives. Alright, so let's begin. Integrals from the derivative of trigonometric functions. So since we know that integral is a reverse process than taking the derivative, so all the derivative formulas that we previously learned, they provide us with an integration formula. And previously we learned derivative of sine x is cosine x, derivative of cos x is negative sine x, and so on. So I'll just derive one formula for the integral formula. So starting with y is equal to sine x, and let's see what we end up with. So we're gonna start with y is equal to sine x here, and we're gonna use differentials. So taking the derivative on both sides, I get derivative of y with respect to x, and we know that the derivative of sine x is cos x cosine x. So from here we got dy is equal to cosine x dx. So this is our differential equation. So in the next step, integrate both sides, take an integral on both sides. So when we do this, integrate both sides. So what we get here is integral dy is equal to integral cosine x dx. And we know that integral of y is y plus c, and indefinite integral of cosine x we don't know yet. Alright, so and if you recall, so I'll call this at number 1. So using number 1 here, what we get is, so y is sine x, so sine x plus c is equal to integral of cos x dx. Thus, from here we got our one formula. Thus, so integral of cosine x dx is equal to sine x plus c. So we started with our y is equal to sine x, and we end up getting the integral for cosine x. So as they are the inverse process, so derivative of sine x was cos x, but if we just use the same relationship, so it's an inverse process, so integral of cos x is sine x. So this will be helpful to memorize the different integral and derivative formulas if you can just make the connections between the different formulas. So similarly, we can start with what we know about the inverse trigonometric functions. Previously, we learned about the derivatives of different inverse trigonometric functions. For example, derivative of sine inverse x is equal to 1 over square root of 1 minus x square. And we did the same thing for all the different inverse functions. So I'm going to use this information and I'm going to try to figure out some new formulas for the integrals. So let's start. We will use the same idea as we did previously. So we'll start with y is equal to tangent inverse x, and then see what we get here. So taking the derivative on both sides, so use the differentials on both sides. So we will do the derivative of y over derivative of x. So derivative of tangent inverse x or arc cosine x, and which we know is this. So we can use this formula here. So we get dy over dx is equal to 1 over 1 plus x square. So we can write this in our differential form. So dy is equal to 1 over 1 plus x squared times dx. So again, like we have done previously, we take the integral on both sides of the equation, and from here we get y plus c is equals to integral of 1 plus x squared dx. And I'm gonna name this as number 2. And since we know the value of y from number 2, so we can write tangent inverse x plus c is equal to integral of 1 over 1 plus x squared dx. So thus we got another formula for the integrals. So if you look here, so below I have given some summary of the integrals of various trigonometric and inverse trigonometric functions. So if we keep on repeating the same process, so we will figure out that the integral of sine x is negative of cosine x plus c. And if you remember the differential relationship that we had earlier was, so this is corresponding to d of dx cos x is negative sine x. So it's always a good idea to see the relationship between the derivative and integral formulas. Similarly, if we think about integral of secant square x dx, so where does this come from? So earlier we learned that derivative of tangent x is equal to secant square x. Similarly, for the next one, the related formula in case of derivatives is derivative of secant x is equal to secant x tan x. And similarly, when we talked about the derivative of inverse trigonometric functions, we learned that the derivative of sine inverse x is minus x squared. Similarly, we can discuss the other set of formulas that we have here. So for example, the integral formula for cos x, we just tried that today. So it comes from the fact that derivative of sine x is equal to cosine x. And similarly, we have, so for cosecant square x, so minus cot x, so we learned that derivative of cot x is equal to negative cosecant square x. Similarly, we had the corresponding, for this one, we had the corresponding differential formula. So that was derivative of cosecant x is equal to minus cosecant x cotangent x. And this one we just learned today, we just tried it, the one we used in the example. So derivative of tangent inverse x is equal to 1 over 1 plus x square. So always whenever you deal with the derivatives or integrals of trigonometric functions, so analyze the form, like how they are related to each other. So if you know one, you can just write the other from the known formula. Alright, so let's try to apply the formulas that we just learned. So let's take a look at this example. Calculate the area between the x-axis and the function sine x over the interval negative pi, pi. So it's always a good idea to draw the graph first and then see how you can calculate the area. Alright, so let's try to draw a graph of sine x. So if we try to draw the graph of sine x, so this is my coordinate system. So I have my x-axis on this side, y-axis on this side, and then let's say this is 0, 1, -1, and then we can try to draw a sine curve. So sine curve would be something like, so if you go from 0, it attains the maximum amplitude, and then it goes back at pi, it goes back to 0. So this is my pi, let's say in between I have pi by 2. Similarly, we can say we have negative pi by 2 and negative pi here. So on this side, we will have the symmetric curve, something like this. So this is our sine x, y is equal to sine x. And since we want the area in the interval negative pi to pi, so I just decided to create the sine wave from negative pi to pi. And we are interested in the area between the x-axis and enclosed between this sine curve. So it means we are interested in finding this area and this area and add them together. So we have as, if you try to figure out the value of definite integral below x-axis and above the curve, so we get a negative value. But since area cannot be negative, so we are here only interested in the absolute values of the integrals. So in this case, of course, we can split our, so one way of doing this problem is, so first method is, right, so first method is you can figure out the integral of integral from negative pi to 0 and add that from 0 to pi. Or other way of doing this is you can simply write that you are interested in the area from negative pi to pi, and we're just gonna deal with the absolute value, and we're just gonna keep the magnitude. And by symmetry, we can see that calculating this is same as doubling, and if you just calculate one of the parts. So we're gonna calculate from 0 to pi, and the value of sine x is positive, the y value is positive in this case. So 0 to pi sine x dx. So just double that value. And we know that, so 2 is just a scalar, you can keep at it as it is. And recently, like today, we learned that integral of sine x is equal to negative cosine x plus c. And in case of definite integrals, we don't put c. So we can just write integral of sine x is negative cosine x, and the limits from 0 to x varies from 0 to pi. Alright, so we get 2. So put the upper limit minus lower limit. So what we get here is, so negative cos pi plus cosine 0. And we know that cosine of pi is negative 1, so we get negative of negative 1, cosine of 0 is 1, so inside we get 1 plus 1, which is just 2, so 2 times 2, so we got 4 units. So area enclosed by y is equal to sine x and x-axis between negative pi to pi is 4 units. Thanks for watching.